Download this code from codegive.com, link in the description below. Shortest path in indirect graphs with unit weights. When dealing with indirect graphs where each edge has a weight of 1 unit weights, the problem of finding the shortest path can be efficiently solved using the breadth first search (BFS) algorithm. This is because BFS explores all neighbors at the present depth prior to moving on to nodes at the next depth level, which directly corresponds to the unweighted nature of our graph. Key concepts. 1. Indirect graph, a graph where the edges have no direction. The edge, u, v, is the same as v, u. 2. Unit weight, each edge in the graph has the same weight, 1 in this case. 3. BFS, a traversal algorithm that explores the neighbor nodes at the present depth prior to moving on to nodes at the next depth level. Algorithm steps. 1. Initialize. Use a queue to keep track of the nodes to explore. Maintain a visited list or set to track visited nodes and prevent cycles. Keep a distance dictionary to store the shortest distance from the source node to each other node. 2. Start BFS. Enqueue the starting node, mark it as visited, and set its distance to 0. While the queue is not empty. Dequeue a node. For each of its unvisited neighbors. Mark it as visited. Set its distance to the current node's distance plus 1. Enqueue the neighbor. 3. End condition. BFS continues until all reachable nodes have been explored. Code example in Python. Here's how you can implement the BFS algorithm to find the shortest path in an indirect graph with unit weights. Explanation of the code. Graph representation. The graph is represented as an adjacency list using default dict from the collections module. Input edges. The edges are defined as pairs of nodes. Each edge is added to the graph in both directions to reflect the indirect nature. BFS function. The BFS shortest path function implements the BFS algorithm to find the shortest distance from the start node to the end node. Output. The function prints the shortest path length or indicates if there is no path. Conclusion. Using BFS for finding the shortest path in an indirect graph with unit weights is efficient and straightforward. The time complexity of this approach is \o v plus e where v is the number of vertices and e is the number of edges. This makes it suitable for large graphs where edges and vertices can be numerous.